This is Grace and Caroline, and this is our Mousetrap project.
We worked really hard on it, and we really hope you guys enjoy it.
We tried to make it creative and entertaining, and it was like really good ending, so pay attention.
Newton's first law is objects in motion will stay in motion unless acted on upon by an unbalanced force, or the other way, vice versa. Technically in this situation with our Mousetrap car, it's technically wrong because the law assumes that there's no friction, but there is, so the friction will cause our car to eventually stop. Some of the factors involved in altering the object's movement are like air drag, friction with the ground, and friction with the parts involved in our Mousetrap car.
Newton's second law is force equals mass times acceleration, and this means that the lighter our car will be, the further it will go with presumably the same amount of force, and this makes us want our car to be lighter because then the further it will go, because we're not necessarily worried about speed since it's just distance based. Newton's third law is for every action there's an equal but opposite reaction, and for our situation with the Mousetrap, that would be the spring. It has all this built up tension and it's pointing in the opposite direction, so then when we want our car to move forward, we're going to release that spring, and then all that tension is going to be released and the car's just gonna shoot forward.
So our reasoning behind our Mousetrap car is we want the lightest car possible, so we don't have a bunch of weight, so the force will increase and it'll be harder for it to go a further distance. And we also, our possible options for building our car could be wood, plastic, and cardboard, and we chose to use cardboard because it's the lightest option possible and it's probably the sturdiest possible, up against plastic.
Speaking of wheels, well, for our Mousetrap project, we thought it would probably would not be within the rule limit to use actual wheels for our Mousetrap project, so we decided to use CDs because they're light and it goes with the the whole light thing going with the force. But we also are going to attach balloons around the edges because we want increased friction. That way our car doesn't just spiral out of control on the linoleum, because that would just disqualify us and not be very good. But we also wanted a wheel to axle ratio to have a small axle and a large wheel, so that way the wheel creates a small force for a long distance, and again, we're not worried about speed because it's all about getting that 2 meters. And we wanted the smaller diameter of an axle, so that way the force of friction is applied closer to the center of rotation and it keeps on spinning until it doesn't. Woo!
Okay, so we glued a longer brass arm to our Mousetrap
Car.
So that our rate of energy would be higher, so it could go further instead of just going a short distance, instead of just all the energy wearing out within a second. But we were nervous about doing this because we were scared that the spring wouldn't be able to hold it and that it would just break right away because it would be so strong, because it would have a lot of tension built up.
Okay, so the motion of the car with work and how the energy transpired is the tension through the spring, when it's not being released, it's just being held there, is potential energy. But when we release that and all that built up tension shoots the car forward, then that will be kinetic energy, which is just energy of motion. and we'll know that work has been done when we like look and see that the car has made it from the starting point all the way to the end destination, which will hopefully be pretty far distance. Just how slow turning.
Yay!
How do I start?
Like,
Oh my god.
I don't think this damn thing. Speaking of wheels, well,
Some of
that's of our actual Mousetrap project. Okay, so like, the wheels we did decide to use are CDs because we. Okay, wait. Can we restart this? That's so far.
we've arrived at our destination.
Yes, where it's going.
He's like watching the thing. He's like.